Hi, hello, good day to everyone. Welcome back to my YouTube channel. In this video, I am going to discuss with you the difference between the two models that I created intentionally here. This model 1 and this model 2. Notice that the setup of seismic primary loads in model 1 is different compared to model 2. In model 1, there are two seismic primary loads, namely AX and AG, both positive directions. While in model 2, there are four, namely AG positive direction, AG negative directions, AX positive direction, AX negative direction. And this is one of the reasons why many STAAD users have become skeptical and confused on which of the two models is better and appropriate to follow. Ang tanong kasi sa ating isa sa mga taga-subaybay, "Good morning sir, bakit AX and AG lang po ang nilagay nyo sa load case details? Hindi nyo sinama ang negative AX and AG? Thank you." So ito kasing model 1 ang ginagamit natin sa ating tutorial. At mas madali kasi siyang gamitin dahil dalawa nga lang ang seismic primary loads. Nang sa ganun, hindi tayo nagtatagal sa ating mga inputs. And we will discuss it here in this video whether it is wrong or not. We will also discuss how to create auto-load combination rules in the combination manager, which is very essential in creating auto-load combinations in load case details. We will also discuss about the process of adding 30% orthogonal direction in each of the seismic load combinations when needed. There are a lot of STAAD users, especially those who have just used this software, have encountered warning messages when adding such 30%. They pointed out that when using manual load combinations, they don't have any problem. But you know, manual load combinations is time-consuming to accomplish. So when using auto-load combinations, they got warning messages when running the analysis. So before we proceed, if you are new to this channel, please don't forget to subscribe and hit the notification bell so that when I upload videos, you are auto-notified. Whenever you like this video, please don't forget to like and share to your friends and relatives who also want to watch and learn this kind of content, and especially to the engineering students. There is no difference between the two models. Whether we use model 1 or model 2, there is no problem with it. Either of the two is correct. When adding load combinations using auto-load generation and load case details, the scenario is that STAAD will come to auto-load rule combination that we created in the combination manager. STAAD reads these combination rules from top down to bottom. Starting at the top, STAAD interprets rule number 1 as rule having did as loading type. Then, it will search for primary loads in load case details that matches rule number 1 and writes equation out of it. For gravity loads, it will match one primary load only, but for wind and seismic, it will find multiple matches depending on how many wind and seismic primary loads are there created. So in the case of this model 1, seismic primary loads are 2. This rule produces 2 equations positive direction, and this rule here produces another 2 equations with negative direction. So STAAD gives 2 equations positive and 2 equations for negative. So it is clear that in this model, seismic loads in negative directions are included in the calculation. So it is also clear that load combinations generated depend on the load combination rules. If we create combination rules wrong, then design calculation will be wrong also. So for recap, in the STAAD editor, load combos 200 down to 22 here are for strength design calculation. So in the table that I created, roll number 1, it has 1.4, right? And the loading type is dead. So STAAD reads it and gives this load combo 1.4 dead based on load case details list of primary loads. Roll 2, which has 1.2 dead, 1.6 live, 1.5 rope live. STAAD gives this one load combo. Roll 3, having 1.2 dead, 0.5 live, 1.6 rope live, STAAD gives this load combo also. Roll number 4, which has wind load. We have 4 primary loads in the load case details, so STAAD gives these 4 load combos. Roll number 5, again it involves wind, so another 4 load combos given by STAAD. Roll number 6, it involves seismic. We have 2 primary seismic loads in load case details, so STAAD gives 2 load combos positive. Roll number 7, it involves seismic but negative 1.25. So STAAD gives 2 load combos here with negative sign here. Same with roll number 8, 4 load combos involving wind. Roll number 9, 2 load combos, and roll number 10, another 2 load combos. That's it. So we are now familiar how STAAD perform the process. Now in model 2, what we would do is just remove this one combination rule. So we see the strength design to table, we have only 8 items here. When we open model 2 and see the load combinations in STAAD editor comparing model 1, the load combinations are there just exactly the same with model 1. This is our model 2, and in the load case details, we have primary load AX plus X, load case 2 AX minus X, load case 3 AG plus G, load case 4 AG minus G. And in the STAAD editor, load combinations are just exactly the same with model 1 I showed to you just recently. So guys, I hope it is clear this time. Note that for any gravity loads, there must be only one primary load to be created for every loading type in load case details. Like for example, here in this model, we have primary load case DL1 and DL2.
What happens is, if we run the analysis, it will give us 18 or more warning messages like this. Let's try running the analysis of this model.
Warning, load command line is too long and will be truncated. So this is wrong. We have to remove this DL2. And if you want to create 2 types of dead load, let's say dead load 1 for all floor load and dead load 2 for all line loads and whatsoever, then really do this in reference load to avoid such error or warning messages. Anyway, I will share the model 1 and model 2 that I am using here for study and practice. The download link is provided in the description box below. If you want, you can check them out. You can download them for practice purpose. Another thing is about the load combinations considering plus 30% of the orthogonal direction.
Many of us encountered this error. Load command line is too long and will be truncated. Basically, load combinations with 30% additional taken from the orthogonal direction is employed only to seismic loads. Let's say we want to apply all seismic load combinations an additional of 30% from orthogonal direction. To do this, we just simply edit all the seismic load combinations in the STAAD editor.
But prior to that, we have to take note the primary load case numbering in load case details. In this model, AX is load case 1, AG is load case 2, DL is 3, LL is 4, RL is 5, and so forth. Then we go to STAAD editor. In here, starting load combinations 100 to 107 are load combinations for drift calculation. So load combinations involving seismic like load combination 100 here. Seismic it means seismic load case at number 1, which is AX. So we will replace the seismic AX with just AX to simply shorten it, and then type plus 0.3 AG. Means AG is the orthogonal direction. That's it. Now we have to edit numbers below also. These are just primary load case number and factors. So here, the load case number of dead is 3. So it is 3 here, and 1.2 is the factor. Next, the load case number of live is 4, and factor is 0.5. Next is AX1, and the factor 1. Next, we will add what we wrote above. We add EG, which is 2, and the factor is 0.3. That's it. And we will do this to all seismic load combinations for drift and strength design involving seismic loads only.
Easy.
So after editing, let us exit this editor and click Run Analysis. No errors, no warnings. Let us check the output. click View Output, then click Done. Take note, it is recommended that the period TV here is less than or equal to 1.3 TE according to NSF section 208.5.2.2 method B. So meaning, TV should be less than or equal to 1.3 times 0.367 or equal to 0.477. And our existing TV is 0.541, which is greater than 0.477. So we have to decrease TV value from 0.548 down to 0.477 or even lesser. To do this, we have to increase the model member size, either columns or beams, that would decrease TV. Or we can import this STAAD file to RCDC to resize all field members, as it is expected field members to have excess when TV is greater than 1.3 TE. But before that, let us also check soft story. It is here. So no soft story. No irregularities either. For drift limitation, all members okay. So let's open RCDC. Click STAAD.PRO Advanced, then click Accept. We fill this up, project name, client name, and designer's name here. Select any save here as design code. Then we browse our STAAD file, then let us first design column, then click create project. We then first go to design settings to confirm if the existing settings is just okay for us. Else, we change what is needed to change. Here we check perform ductile design, and this is important for structures within zone 4. Let's make this 0.5 strength reduction factor for shear. You can check table 208-11A, 208-11B, and 208-11C of NSCF. Then I would like to uncheck optimized design, so RCDC will provide one rebar size only in column for the whole height or beam for the whole span. Then click OK. Next, go to reinforcement settings here. In this portion is the steel reinforcement percentage against concrete. Normally, the maximum is 8%. But to avoid over-reinforce in the region where splicing occurs, and to avoid heavily congestion such area as well as in the column beam joint, we reduce 8% down to 4 according to the code. So this is okay here in this portion. What we need to change is the rebar size. For me, I need 16, 20, and 25 for longitudinal rebar. Shear wall, we don't have shear wall in this model. Link as is. Down here are the links for columns as well as shear wall. Leave them as is. Click OK. Next, in the label data tab right here, we need to change the cover for columns and beams. It is usually 50 or 50 millimeter, or you can refer to section 420.6.1.3.1 of NSCF. Next is basic load combinations. So here earthquake AX, earthquake EG, dead load, live load, rope live, wind X, wind X, wind G, wind G. Highlight all this, then bring them to the right by clicking this double arrow here. Click Add from Analysis, then click No. When we design columns and beams, we select the load combinations for strength design, and in our STAAD file, those are starting from load combo 200 down to 222 only. So we will uncheck everything that is out of this range. So just highlight we want to exclude, then after highlighting, right click and click unselect. Then click OK. So we found out that a lot of columns filled in the design as what we expected. So we will increase the size of columns here, and this would decrease our TB once we complete these columns. After resizing columns, go to File here and click Update Analysis File. In this way, all the changes that we have been doing in here will be transmitted to a STAAD file. Then close RCDC. We will open STAAD to update the file applying the changes. Here, we must run the analysis to have new output. Now if we take the period TB for the second time, our new TB is 0.417, which is now less than 0.4771, which is just fine. So now let's further proceed to designing the beams, but we will do this in the next video. And this is enough for today's episode, guys. Thanks a lot for your precious time. See you in the next episode. Bye.